Respected Dr. Ranjana Nalamali, Directorate of Futuristic Technology Management, DFTM, Professor Akhilesh Tyagi, Chairman, Governing Board, Shriram Scientific and Industrial Research Foundation, Delhi, Shri Madhav B. Shriramji, Vice Chairman, Governing Board, Shriram Scientific and Industrial Research Foundation, Delhi, our esteemed members of the Governing Board, members of Research Advisory Committees, Their Excellencies, the Ambassadors and the High Commissioners, Dr. Mukuldas, Director, Shriram Institute for Industrial Research, Delhi, invited dignitaries, ladies and gentlemen. I, Leena Thabal from Shriram Institute, Delhi, take immense honor to stand before you today and pay tribute to our illustrious founder and one of India's most distinguished industrialist and philanthropist, Lala Sir Shri Ramji, marking his 142nd birth anniversary on this Shri Ram Founder Memorial Lecture 2026. Lala Sir Shri Ramji, a titan of Indian industry, a harbinger of progress, and an unwavering adept at education and scientific research. His legacy is indelible in the annals of India's economic and intellectual evolution. He did not only merely build an industrial conglomerate, he laid the background for modern Indian enterprise, shaping the trajectory of industrialization in the country, and thus was regarded as the father of industrial research in India. Shriram Institute for Industrial Research was not only started by him in 1947, but became a beacon of excellence under his vision, resolute interest, and generous support. The Institute today stands as a living testament to his indomitable pursuit of progress. Since 1965, every year, scientific lectures have been delivered by eminent personalities from across the globe, thereby making this a major scientific event of the country. Today's Founder Memorial Lecture, which is 60th in the series, is being delivered by Honorable Dr. Ranjana Nalamali, Directorate of Futuristic Technology Management, DFTM. A big round of applause, ladies and gentlemen. Across diverse cultures and traditions, the act of lighting a lamp holds a multitude of profound implications and resonances representing the triumph of knowledge over ignorance and light over darkness. Now, we'll begin the program by lighting the ceremonial lamp. May I request our dignitaries on the dais to kindly do the honors, please. Lamp has been lit, and with its gentle yet unwavering flame, guiding us symbolically towards wisdom, knowledge, and mutual growth. To pay homage and tribute to our founder, may I request Dr. Mukuldas to garland the bust of Lala Sir Shri Ramji. May I now request our respected Professor Akhilesh Tyagi sir to kindly facilitate Dr. Ranjana Nallamali by presenting a bouquet to her. Welcome, ma'am. May I request Dr. Mukuldas sir to kindly facilitate Professor Akhilesh Tyagi by presenting a bouquet to him. Thank you, sir. I now request Mukuldas sir again kindly to facilitate Shri Madhav B. Shri Ram ji sir by presenting a bouquet to him. Thank you, sir. As we move further, we'll take a pause and recognize the values, dedication, and spirit that unite us. We now proudly unveil the symbol of our identity and purpose, our SRI anthem. This SRI anthem has been thoughtfully created to reflect who we are, what we stand for, and where we are heading together. It is a tribute to our collective journey and a reminder of the strength we draw from one another. Please join me in listening to the official SRI anthem. SRI anthem team. I now request respected Dr. Mukuldas to deliver the welcome address, please.
Distinguished guest speaker for the afternoon, Dr. Ranjana Nallamali, respected chairperson, Dr. Professor Akhilesh Tyagi, respected vice chairperson, Shri Madhav B. Shri Ramji, members of the governing board and research council of Shriram Institute, distinguished guests, dignitaries from various embassies and high commissions, faculty members of universities and colleges and research institutions, members of the electronic and print media, my dear colleagues, and my dearest students. A very good morning, or we can say afternoon now, coming to reach us, to all of you. At the onset, I would like to pay my gratitude to Dr. Ranjana Nallamani, who accepted our invitation on a very short notice. I would say that only last night. And that too, because Dr. Samir Kama is involved in a very important meeting today. And she accepted our invitation on a very short notice. And we are so glad that she could able to make it up to give the Founder Memorial Lecture to all of us. As we gather today, we unite in reverence to celebrate the extraordinary legacy of our illustrious founder, Sir Shri Ram, on the momentous occasion of his 142nd birth anniversary. And it is my privilege and profound honor to extend a heartfelt welcome to each one of you at this distinguished assembly. Together we commemorate his enduring vision and values through the 60th Shri Ram Founder Memorial Lecture, paying tribute to his memory. Sir Shri Ram was more than a visionary ahead of his era. He was a trailblazing industrialist and a builder of institutions that shaped the future of our nation. At a critical moment in India's journey to independence, he established several academic and cultural pillars, including our Shriram Institute. His courage, foresight, and commitment to the nation building continue to inspire us, reminding us that true leadership lies in creating opportunities that uplift society for generations to come. The light of Lala Shri Ram's vision was carried forward by late Dr. Bansidhar, whose able leadership guided the Institute to new heights of excellence. Today, under the stewardship of Sri Madhur Shri Ram, this noble legacy not only endures but continues to flourish the spirit of innovation and service that has defined the Institute since its inception. In the year 2025-26, scientists at Shriram Institute achieved significant milestones in research and innovations. Apart from providing services to industry and government sector, they published several research papers in leading high impact factor journals. And besides publications, our scientists actively contributed to the global scientific community by delivering numerous presentations and lectures at prestigious conferences and professional meetings. Innovation remained a core pillar, evidenced by the granting of two major patents, one for a degreasing and cleaning composition and the other for X-ray shielding composite tiles utilizing e-waste residues. The Institute scientists contributed to the formulation of 5 new Indian standards related to vitamin determination in foodstuffs. In terms of commercialization, a technology know-how for an herbal energy drink was successfully transferred for industrial production. The Institute acted as a hub for knowledge dissemination, hosting numerous exposure programs for students from Delhi University colleges, including Ramjas, Hansraj, Sri Venkateshwara. Staff and scientists also engaged in extensive skill enhancement. For example, they attended the advanced training course in radioactivity testing at Bhava Atomic Research Center and for flexible pavement design at CSIR Institute at Central Research, Road Research Institute, Delhi. Individual excellence was highlighted by some of the scientists, including Dr. Jagdish Kumar, who received the Best Researcher Award for his work in environmental chemistry. Dr. Amita Dhimri was honored with a citation at National Education Conclave, New Delhi. Mrs. Radhika Sharma secured third position in oral presentation at a conference for food scientists and technologists at MIT University, and some more awards were given to our staff members. Additionally, faculty members served as external examiners and subject matter experts for FSSAI, Bureau of Indian Standards, and Indian Pharmacopoeia Commission. The Institute significantly expanded its network through new renewed strategic alliances. Formal Memorandum of Understanding were signed with Vivekananda Institute of Professional Studies and CSIR, National Geographic Research Institute, Hyderabad, for mutual technological services. Existing partnerships with MIT University, Jamia Hamdard, and Kirodimal College were renewed to foster academic and research continuity. Looking ahead, under the visionary leadership of our chairperson, Professor Akhilesh Tyagi, and Sri Shriram, we continue to build upon the strong foundation laid by Sir Shri Ram. Though much has evolved over the past 7 decades, the guiding vision of our founder remains steadfast, inspiring us to confront society's most pressing challenges even today. It is therefore my distinct honor to introduce our distinguished speaker for today's event, Dr. Ranjana Nallamani, for a lecture delivered in tribute to the memory of our founder, which promises to be both enlightening and inspiring to all of us. I am confident that her insights will resonate deeply with us and further strengthen our collective commitment to innovation and service. Thank you all. Jai Hind.
Thank you very much, sir. May I now request our very respected Professor Akhilesh Tyagi, sir, to kindly introduce the speaker.
मैं क्लोजअप ले रहा हूँ, फिर से बोल रहा हूँ तेरे को।
Honorable Shri Madhav B. Shri Ram, Vice Chairman Governing Body, SRI, Dr. Mukul Das, Director, SRI, distinguished luminaries on the dais and off the dais, invited guests, media, and staff members of SRI. We are here today to listen to the 60th Founder Memorial Lecture by Dr. Ranjana Nallamani, who is outstanding scientist and director for Futuristic Technology Management, DRDO, New Delhi. And we are also celebrating great contributions of the founder, Sir Shri Ram, to the Institute and Science and Technology Development in India since the time of independence. Dr. Ranjana Nallamani started her career with DRDO in 1992 at NSTL Visakhapatnam. Presently, she is heading the Corporate Directorate of Futuristic Technology Management, DFTM, which is chartered to focus on translational research for developing the crucial and futuristic technologies in identified research domains. Under her guidance, DFTM undertakes the major activities to plan, implement, and manage the directed research collaboratively. Prior to present assignment, she has spearheaded the Corporate Directorate of System and Technology Analysis, DSTA, and worked on identifying the new futuristic technologies for various defense and related applications. Technology oversight of DRDO incorporating 75 tech priority areas have been publicly released due to her visionary efforts. Dr. N. Ranjana has been instrumental in developing various standards and policies for software development in DRDO. She is a life member of many technical societies and think tanks and is well acknowledged speaker in all technology and strategic forums. She is an avid reader and has authored many articles sharing her scientific temper. During her career, her contributions in every position held by her have been acknowledged greatly. She has been recipient of various lab level and DRDO level awards for her significant scientific contributions to strategic productions and implementation of organization-wide policies and automation of business works. It is a pleasure to invite Dr. Ranjana Nalamali to deliver 60th Founder Day Memorial Lecture. Dr. Ranjana.
Good noon, ladies and gentlemen. We are just about to reach the 12 o'clock and I don't know whether to say morning or the evening, so good noon to everyone. Actually, we are all here because we are standing on the shoulders of giants, and today I am deeply honored to get this opportunity to come here and speak to all of you on behalf of my secretary, who has been called for something very urgent, and late night I got the call that I have to fill in the shoes. I'm not sure I'm going to do the justice, but I'm trying my best. That's a promise. And my greetings to Shri Shriram, and who has been actually keeping the legacy of Sir Shri Ram, whose memorial lecture today I'm trying to attempt and trying to say where the RDO and defense R&D is going. Professor Akhilesh Tyagi, happy to meet you today, but within short time, whatever I know, a lot has been done and contributed by these giants who are sitting on the stage. Very honored to be introduced by you, sir. Dr. Mukul Das, of course, a well-known scientist and R&D enthusiast who has been bringing in the culture of R&D. I think we need not just one Dr. Mukul Das, we need many of them all across the country. Now, coming to the topic that we have, the governing board members and the research council of SRI, very happy to be here, and in fact, I can relate to you very well because of late my job and my responsibility has been to fund R&D across various institutes, which actually includes all the IITs, including ISC and all other institutes wherever the R&D is being done. R&D is seeing a major shift today from the earlier days where R&D was considered only as the paper publishing and to some extent patent formulation. Things have been changing very fast in the country because there's a major government push to convert this R&D into the products. And DRDO has taken a full cognizance of the fact we have accelerated our efforts towards the defense R&D. I will come to that how we are trying to reach out to the larger community
in various schemes. But before that, let me just come being part of the DRDO, where I've spent almost 33 years now. And every day I have cherished, I have learned every single day what it means to be part of DRDO and Defence R&D, the seriousness of every single work that is being done. Being part of Torpedo program, Agni program, and last 10 years at headquarters has given me tremendous overview of what Defence R&D has to be and how it is to be shaped. The vision we have is the world-class science and technology base for providing the defense services a decisive edge in the war games. But the war game has been changing. The warfare scenario has been totally changing. And for that, you need the cutting-edge technologies, state-of-the-art sensors, weapons, platforms, and the allied equipment that is being required to actually augment you for the war. And we also advise to MOD on various scientific aspects of weapons, platforms, and surveillance sensors, which are also being procured in many ways. Cyber defense capabilities are being on a lot of focus, and a lot is being developed on these areas. And the next domain today, the space defense domain, is also being given the focus. So from the air, water, and land, we have moved to cyber and space domains seamlessly. DRDO is divided into 7 technology clusters and 4 corporate clusters. There was a 5th one which has been recently dismantled and distributed among the technology clusters. These technology clusters focus on missiles and strategic systems as MSS, naval systems and materials for platforms, weapons related to the naval domain, aeronautical systems primarily focused on the fighter aircrafts, the UAVs, and the constituent technologies like engines, armament and combat engineering, ammunition, guns, the tanks, the other bridges, whatever is required for the combat engineering, the ground combat engineering. Microelectronic devices, computational systems, and cyber system, needless to say, today the most important part of every single system and platform. And for the man behind the machine, soldier support systems is also doing multiple activities to make the soldier comfortable or survive under the adverse situations. The corporate clusters actually support all these 7 technical clusters in terms of HR, in terms of coordination with services and industry, in terms of resource management, budgeting, finance, the sanctions, and the technology management. Technology management is one cluster which is primarily reaching out to the industry and academia in a very comprehensive way to do the research for all these 7 clusters, to take help of the external environment and help all these 7 clusters in every form possible. So there was a 25% R&D by industry and academia, the mandate given in 2022 budget by the Government of India, and this cluster is reaching out to fulfill that dream so that all our endeavors, wherever whatever help is available for defense R&D, will be garnered and provided. So I'll talk about it as I go. So today we are divided into 3 major verticals. We do a lot of deep research on certain science with the help of industry academia. Technology development, we have 40 laboratories, and this technology development is done primarily with the help of industry, and to some extent wherever the academia is able to reach the higher TRLs, we take their help. System development is primarily done with the help of industry as well as the in-house development. So the primary prototype is developed in the labs and then it is given to the industry. So we have come up with a lot of collaborative schemes with the help of the people who are in this particular area. So I will throw some more light on it, but let me come to the missile systems. Today India is working on Pralay missile, which is the next generation surface missiles. I am not talking about the systems which are already deployed, the ones which are totally in vogue and the latest systems. Nirbhay missile, the subsonic cruise missile, and the BrahMos, which we all know. The SAW is a smart airfield weapon. The general purpose bombs, a lot of configurations are being worked out as needed, the range, the weight and whatever. So missile system is something that we have mastered various constituent technologies, and whatever required can be configured based on the requirement of the armed forces. And if you see the SAM, surface to air missiles, which are the major protection against the incoming threats, is LR SAM, QR SAM, Akash NG, and Akash is also configured for Indian Air Force, Indian Army in various configurations. Anti-tank missiles, Nag, Helena, MP ATGM, Sun, and ATGM for Agni. So these are the configurations which are, adopted or a bit of a designed or configured for a particular platform or a particular usage. NGARM is anti-radiation missile to counter the. So you must have heard the Iranian war, which has just gone through. The first radars were neutralized, and the radars are neutralized by the anti-radiation kind of missiles, and we have our own indigenous NGARM. MBRLS systems is multi-barrel rocket launchers, which is Pinaka and its next generation systems. We also have the Astra BVR missile, which is air-to-air launch missile. So every segment of the missiles, we have the complete design, indigenous capability to protect the nation through every platform and through every vector of defense. Armored vehicles and land systems, we have MBT Arjun, wheeled armored platform, Sarvatra bridge system. We have many multi-bridging systems are there to cater the need of various sizes, various terrains, as well as the various kind of loads that it has to bear for various purposes. So in bridge systems and in we are totally indigenous, of course with the help of industry, and most of these bridges are being manufactured today by the Indian industry and deployed. Artillery and gun and ammunition systems, ATAC system, developed with the help of two industries. We call it as DCPP, the Development Cum Production Partner. So DRDO and industry work together to bring out two configurations, and this is the longest range ATAC systems in the country in the 155mm range. The JVPC and 9mm machine pistol has been indigenously designed and being produced. Grenades, types of gun projectiles, ammunition, and various programs which are for the munition, anti-tank munition, they are being matured and being developed and produced by various partners. Aerospace and aeronautics, LCA, we all know it is being inducted into the Indian Air Force. 83 fighters are being inducted for the pure combat operation, and 10 trainers are being given to Indian Air Force, the production agency being HAL. So it's such an interesting program that in LCA program today, the Mark 1A, and I think shortly we are going to have for Mark 2, and Anka is under the design. There is 140 institute which basically worked out on the various smaller components, studies, algorithms, indigenization efforts, and the single program was handled by the ADA to bring out this particular complex machine. So what we talk about today, LCA, is not just DRDO or ADA, it is every single person who has contributed towards making maybe a smaller portion which is not visible to the outside world, but is there in the functionality as it flies. You feel pride in that particular system which everywhere everybody contributes in the country. But the program management is also very effective to utilize what is good available wherever to get it and use it. LCA Navy, it landed on the INS Vikramaditya. It was a big news, and I think it successfully took off, and the technology is proven indigenously in the country. Netra, which plays a very crucial role in terms of the surveillance and the airborne EW kind of a system, where it is having electronic support measures, radar warning receivers, as well as the communication support systems. Now, it's a complete system, ISR surveillance systems in the air to perceive the threats and guide the combat systems behind the scene. And this is one of the unique capability of our country, which I think not more than 4 countries in the world are having. And this has been used in the Operation Sindoor last year very effectively. Unmanned aerial systems, plenty of the unique, unmanned systems, aerial systems, there is a large canvas starting from 50 grams to the kind of UCAV that we talk about. So there is an entire gamut where industry is playing a very crucial role to get certain kind of systems which are possible for industry to take it up. So those systems DRDO is not working on, but there are very niche areas where DRDO has put its effort, especially for the ISR purpose and for the kind of situational awareness systems, where DRDO has made certain technologies and indigenization of the constituent technologies. So these are some of the examples which DRDO has made, and they are being used effectively in their application areas. Radar systems, so these are all deployed radar systems. India is totally capable of indigenous radar systems of all types, and today we are working on all next generation radars. These are the radars which are deployed by Indian Air Force, Indian Army and Indian Navy. The logos themselves are there that you have. These are all deployed systems with our armed forces and being in use. And today LRD, our lab in Bangalore, is working on the next generation radar systems for miniaturization, for better algorithms, for better electronics. So there is always a next generation of the systems. EW systems, India has been in works, and there are various systems which are Naval, Air Force, Army, all have been deployed in various systems, and they are under operation. In fact, yesterday itself we had a very good demo at Hyderabad, Samrakshak, where the anti-drone systems have been, how to manage the anti-drone warfare with the help of EW systems has been demonstrated. So a good amount of electronics development has been deployed and given to the Indian Armed Forces. These are some more airborne, shipborne and ground-based EW systems. There are systems which are also being deployed on the satellites, on the Indian Navy ships, and many of these things are kind of things which we will not be able to talk much in detail. Similarly, communication systems like software-defined radios, data links for airborne systems, troposcatter communication systems, SATCOM terminals have been designed and developed by the DRDO. Naval weapon and systems, the torpedoes, the short-range torpedoes, long-range torpedoes, they have been designed, developed, tested and deployed with the systems, and there are anti-torpedo defense systems. So when you make a weapon systems, you also have to think of the countermeasures which are required to be done, and all these systems are designed by the DRDO lab, which is NSTL. NPOL has designed the sonars. Today all Indian naval ships are having indigenously designed sonars. The production partner being Bell, and every single ship is carrying today the indigenous sonars designed by the lab called NPOL at the Cochin. Submarine sonars, it also has the off-board sonars and auxiliary systems required for the sonars. In addition to all these sensors, devices and advanced materials are the area of focus, the current area of focus. Many of the sensors are imported, but there is a lot of effort being taken up by the core science laboratories along with the R&D by academia to make advanced sensors indigenously. The semiconductor mission, with the help of semiconductor mission, many of these activities have got accelerated, and I think as we speak, a lot of indigenous chips are being designed which will go into the systems. Till now the chips were being imported, but many of the chips are also being designed in the country. So soldier support, I talked about the man behind the machine. be it telemedicine, the combat ration, the high quality ration for the the amount of calories, calibrated amount of calories required for the particular areas, be it high altitude or be it desert warfare or be it the plains. The ration is designed and defined by our own laboratories in the country. One-man Hapo bag was made for the purpose of soldier survival. Bukhari is required for the very high altitude areas like Ladakh, which is a very convenient and a very miniaturized system deployed with the armed forces. The combat casualty care regimes and the the kind of you need to give certain kind of guidelines. They are all being done. Combat free fall system, flight G suit, the protection gear like helmet, masks, the cold weather clothing, hot weather clothing, all kinds of research is being done at DRDO laboratories. The air purifying systems, whether it's for submarine or for the aircraft OBOG system, the exoskeleton for augmenting the soldier for his abilities. All these systems are being designed in various parts as per the need of the soldiers, and many of them are already being used and deployed. Now, India is an exclusive club. I have just jotted down a few of them. It is the first country for the world's longest range gun of 155 mm ATAGS, and it is developed with the two industry, and now it is under production. We are shortening the cycle from the lab to the field trials to the user trials in a way that if we develop with the industry, the field trials and user trials get compensated. And this gun is being productionized already by two very big industry partners. India is one of the 4 countries to have made air independent propulsion, which is a fuel cell based AIP for the submarines. It is one of the 4 countries to have demonstrated the capability to counter a satellite by killing its own one of the defunct satellite in the space using our ASAT missile. It is also one of the 4 countries to have ballistic missile defense program, which is very successful, either endo-atmosphere or exo-atmosphere, both the vectors it is able to handle. Then we have one of the 5 countries to have evac systems, our own ISR laboratory in the air. It is one of the 6 countries to have this strategic triad capability, and that's the kind of the technology that is deployed today for the protection of the nation. It is one of the 7 countries to have fully designed, developed and is now under manufacturing the MBT tank. The 4+ generation LCA Tejas is one of the 7 countries to have designed this fighter aircraft, and which has paved the path for the next generation fighter aircraft, which DRDO is diligently working on. We have developed very, very advanced test infrastructure. So when we make all these platform systems and claim that we have so many systems or so many platforms, it cannot happen without the kind of the infrastructure, the test regimes and the test infrastructure that we need to actually first design them, then qualify them, and then do the field trials. So I mean, there is a lot of test infrastructure across the country to do this design and development. I'm just highlighting which are one of the cutting edge kind of test infrastructure available in the country. Hypersonic wind tunnel test facility at Hyderabad, sea keeping and maneuvering basin facility at NSTL Visakhapatnam, aeronautical test range Chitradurga, and many of the startups and many of the industry partners are also using this facility for many tests to make their own systems. Then orange test facilities for the instrumentation, for the, actually this is for the communication testing while flying of the UAVs. And then extreme altitude research center at the Leh, Changla. So this is something that these are one of the top class, but there are about 100-150 more test facilities which are uniquely required to make these systems. And these are open to the industry partners who are working on the defense design and development. The future roadmap, we need to, so there is a roadmap laid down by each of our labs working in systems and technologies. Underwater domain awareness is an emerging area. Space situational awareness is an emerging area and is a ask which is very important as of today due to emerging warfares. We have ISR which has to go to the next generation. The current ISR capabilities need to be enhanced, augmented. Robotics and unmanned systems will become the call of the day. A lot of work is going on that. Man-unmanned teaming in terms of unmanned warfare, coming up with the manned systems and platforms. These algorithms, these protocols, these regimes and working together will become very important, and it's a very important part of the technology. Cyber defense, the more I say, I think it will not be enough. We will need an entire topic of discussion of the cyber defense that needs to be worked at. Network-centric warfare, I think without that, and as we speak, there is a deep work going on in integration of various vectors and the network-based operations, network enablement of the systems, network enablement of the soldiers, and the platforms included. So next generation platforms that we are working on is AMCA. We all know the work has started, accelerated, the program is sanctioned by the government. Twin engine deck-based aircraft, fighter aircraft work has been started. RPSA is the next generation platform UAV which is required for the armed forces. High altitude, long endurance UAV is also being in the works. I think shortly we will have the flight trials. Stratospheric airship or high altitude platform, deep design work is going on. AVAX Mark II is in the works, project is sanctioned. High endurance autonomous underwater vehicle. The indigenous conventional submarines are being made. We were making indigenous strategic submarines, but the conventional submarines are also design and development work has started. Future ready combat vehicles, future infantry combat vehicles, unmanned ground systems and robotic soldiers. These are some of the platforms and the capabilities that we are building. Weapon systems and sensors, again the next generation work has been started in the hypersonic range, hypersonic glide and cruise vehicles, both have been started. Very long range air-to-air missiles, the Akash has been surface to air, but Astra air-to-air has been quite effective in the war, but now the next generation increasing the range for better homing, all this work has been started. Rail guns, directed energy weapons, a lot of work has started. The next generation torpedo in terms of supercavitation capabilities, very long range radars, sonars. I think this all EW system, next generation EW system, electric propulsion for ships and EMOL systems, aircraft launching system based on electromagnetics, the work has been started. Hypersonic is a very, very niche technology, and if you see this technology, there are very few countries which have mastered it, and we are the third one, I think, in the world. The kind of materials that we require, which are required for high temperature, which that particular missile has to sustain, and the kind of mechanical engineering is a challenge. And we had the first flight, and on ground a lot of tests are being done, and I think this particular system is going to be seeing the light of the day very soon. And I myself am aware where we are taking the help of multiple academia to help us with the high temperature materials which are to be sustained during this Mach 5 kind of operations. So this is something that a lot of work is going on. This is the kind of configuration that needs to be worked on. We really, I mean, this is just something which is showing that what is the range of the cruise missile, hypersonic and the glide vehicle and the ballistic missile. So this gives a snapshot where the ballistic missile operates, where is the boost glide vehicle, the hypersonic glide vehicle operates. This is the kind of trajectory it takes, which is given in the green. The blue is the thing which basically your hypersonic cruise vehicle operates and the normal cruise vehicle, the kind of comparison. So the kind of technologies which goes behind operating each one of them is the next generation. Once you have to, so the glide vehicles will require a different kind of aerodynamic configuration and controls. The cruise missile, when you want to go for supersonic, it is again a different kind of technology. So many of these technologies are in the works and are being worked about in the, as we speak. The intention is that if we can cross the 2000 kilometer mark, we can easily go to the 15,000 kilometer mark once the technologies are honed. So this is something on the hypersonic scramjet engine. A lot of work is going on various places, including the Hyderabad-based laboratories. And if you understand the difficulty, the impact energy of this particular one missile with minimum payload can be equal to the several tons of the explosives. So the impact is so high, and that is why this particular technology is of so much importance to the defense of the nation. This is the scramjet powered hypersonic vehicle challenges, the speed, the scramjet, shifting from ramjet to scramjet operations, the kind of design that is required to sustain the deep aerodynamics, the engine development, material selection, fuel development, and thermal management. So these are the challenges we are working on. About 50 small projects are on just to understand every small aspect of a thermal or the fuel or the materials at multiple institutes, and we are on our task to make sure that everything works and falls together to make this particular missile. The new technologies that we are working on, needless to say, AI, application of AI in every single domain and vector of platform or the system. Quantum technologies, a lot of work is going on, either it in communication or sensor. We were the first ones actually to demonstrate the quantum entanglement-based communication, which is the free space at IIT Delhi. Quantum technologies, we are working on the quantum magnetometers as a part of sensing part. Many of the cognitive technologies are being taken up. Photonics, a lot of work is going on. The chips are going to become next level efficient with less power required with the photonic technologies. Terahertz technologies will be very important for sensing, communication, and also the imaging part of it. Stealth and anti-stealth technologies, a lot of it is happening. Hypersonic missile defense, next generation sensors, indigenization of certain critical sensors, directed energy weapons and anti-directed energy technologies, the countermeasures, compound semiconductor materials and devices, as I speak, GaN, gas, gallium, aluminum arsenide. So a lot is happening at the core technology level, focused towards where it is applicable in the defense systems, what can be deployed. So you won't see in a gun, you won't bother what is the material, but there is a lot that goes into making that barrel or the body that you are talking about. So we are targeting the every segment of technology development for the efficient and optimized design required for the armed forces. Much work is going on. PQC, very important for defense. Propellant and explosives, long history, a lot of it is available, but next generation optimization of weight, better ISP, specific impulse, all this work is ongoing. Then what we have is, we have also taken certain measures to bring or empower the younger generation to do their bit. 5 young scientist laboratories, they have been given the deep tech areas, that this is what you are left to your own, please work on these deep tech areas, and they are producing fantastic results. The scientists less than 35 years, including the lab director was less than 35 years. The AI lab at Bangalore, DYSL, we call them Defense DRDO Young Scientist Laboratories. asymmetric technologies which are working on drone swarms, remote sensing, non-contact warfare, cognitive sensor technology with DYSL at Chennai. Smart materials also is working on shape memory alloys and the advanced kind of materials, computational materials technologies. Quantum Technology Lab at Pune is working on the quantum computing, communication, sensors and security. These are some of the cognitive technologies that we are working on: cognitive radar, edge-based AI deployment, explainable AI and cognitive computing. It's very challenging, very difficult, but yet the young generation is doing its bit, and I think we are getting very good breakthroughs from them. Smart materials is something that we are working because something that India did not really focus other than on steels or meraging steel kind of thing, but advanced materials, a lot of work today, there's a lot of focus by DRDO on the advanced materials, and these are the range of materials from high temperature materials to bio-inspired microchips. We are taking up the entire gamut, focused on the defense applications and working on these materials. AI, I talked about it, every single platform system, wherever the AI application is there, the application specific AI work is going on, which includes the edge deployments. Without the edge deployment, it will be difficult to use AI. AI for vision, biometrics, AI for natural language processing, AI for speech, deep learning from the census data. These are some of the products where the AI is being applied, something like smart helmet, face recognition system, speech processing, also the night sight, and recently AI products have been, one of the product called Samad has been handed over to IDS, headquarter IDS, for UAV detection and the UAV guidance. And yesterday itself, AI application has been handed over to MHA called Samad for their usage. Quantum technology, quantum computing, the 6-bit qubit computer is working at DYSL AI at Pune. Quantum communication has been, entanglement-based communication has been demonstrated with the help of IIT Delhi. Quantum sensing, a lot of work is going on. Random number generator, the TOT has been, first generation has been done as transfer of technology to the industry. The second generation QRLG chip is ready for TOT. Post-quantum cryptography deployment has been going on. Now this is one slide which I want to just say how we are talking to the external world. So we have certain schemes to talk or utilize the whatever capability available in the country for the use of the defense research. We deal with a lot of academia with the help of our scheme extramural research, which has been in vogue for last 60-70 years. We have been sanctioning a lot of R&D projects. We have research boards which do it in the focus area of life sciences, or it is ARM-REP, which is the armament, then ARNDB, which is the aeronautics, and also the kind of work which is happening for the materials, which is the naval board. Now, this was already there for a couple of years. Last 5 years, we have started the Directorate of Futuristic Technology Management, which we are driving, and we have 15 centers of excellence, which is called DRDO Industry Academia Centers of Excellence. The role being played is to bring the 3 pillars together to cut down on the valleys of death which happen between the academia and the final deployment, bring in industry, bring in DRDO all together to work together to enhance the TRLs from TRL 2 to TRL 6 so that it gets used, or a lot of innovation is happening in all our academia. But it is not being adopted easily, or something is getting lost in the translation. So these DRCOAs have been formed to plug that translational gap and quickly bring the technology from the tabletop to the deployment ready. And with this, the culture of all 3 is being encouraged to rise above the comfort zones and bring together the product orientedness. Similarly, we are dealing with industry very effectively. We were doing the transfer of technology as a conventional way. The speed of transfer of technology has been increased, so we are quickly going to industry to do the production. We have also started a new scheme called Development Cum Production Partner, where all the mission mode projects we take up along with industry, so that industry and DRDO design together, produce together, so that production orders and all are combined for at least the prototyping stage. And if it is successful and field trials are done together with the help of the armed forces, whosoever is the user, so that the production can start immediately at the end of development instead of having the gestation period of field and user trials. So this DCPP, Transfer for Technology, we have another scheme called Technology Development Fund, wherein the industry is directly given the funding to do the technology development at their end with the help of the DRDO labs. So instead of everything going through the lab, dedicated fund is given to the industry who has the capability, ideas, wherewithal to make a technology on their own which can aid to the defense program. So a very large canvas has been opened up for us to, it's also a government wants it that we take R&D help from wherever it is possible, and I think we are doing our best to get the best collaborations possible with proper work shares and the accountability built into this R&D. So these are the 15 centers of excellence that have been established. We have been anchoring it from DFTM very effectively, and these are the major research areas which are being under focused. It's ballistic and protection technology, the next generation, indigenization of materials, advanced electromagnetic devices, terahertz technologies. I don't want to read out because this is all available on my website, drdo.gov.in, and you can have a glimpse of all these areas. So I made it very busy slide because I don't want you to read it. You can just go to drdo.gov.in, and all these verticals, all these futuristic areas that we are focusing on to translate research into innovation is something that we are looking at. So we are trying our best to convert our research strength to the innovation. If you ask me, we are ASPI tracker, which gives out the technology ratings of the countries in various 74 technology areas globally overseen. India figures out in top 5 is almost 60 technology areas, and that is owing to our publications and their research and their references, which are very high quality. Now the time has come, our innovation index has to inch up, and for that innovation index to inch up, we have to convert this research to the products and make our products high tech, deep tech, as well as using the latest technologies, and should be produced in the country. So that's the aim. So these are some of the research proposals that we have launched on our website. This is basically October 24, February 25, June 25, and last one in somewhere in August, February 26. Now, these problems are very challenging problems from academia, but we want academia to take these challenging problems. The idea here is we don't withdraw them because many of them are still not solved. So it's not a limited time call for proposal by DST or DBT, but it's a call for proposal that I really need to solve these problems with the help of the industry or academia. And now the challenges that as DRDO we face is that we have extremely good work experience in cutting edge defense systems. System engineering is one of our forte, which DRDO has garnered over the last 60 years of our system engineering, system deployment, system testing, and finally delivering the systems. Whether it's land, air, marine, space, emerging and disruptive technologies. Cross-domain expertise is available with DRDO, but it needs to be developed in the entire ecosystem. And we have the system engineering, but system engineering thinking has to be more prolific across the ecosystem that we are trying to develop as a defense R&D ecosystem. Academia engagement is something we have been doing it, but it has to go to the next level of converting the academic output to the real innovation and product output. Industry engagement, we are trying our best to engage industry at the earliest, but a little bit of R&D by industry will become an add-on to all these efforts, because industry is very good at production. They have been doing it very well, very optimized. A bit of R&D by industry to aid the system realization will go a long way. So each challenge is an opportunity. Services engagement is to be more deeper and continuous, which is being also enabled by various joint technology groups, so that there is less communication gap between what armed forces want and what is being developed as a defense system. And DRDO is one opportunity. We have a lot of breadth and lot of depth in terms of certain areas. We need to now embark on the next generation technologies. And today the world, the commercial technology is also moving at a very fast pace. Like AI, something like AI, a commercial development is very, very fast. Now there has to be a strategy to adopt that pace. May not be as it is the technology, but that pace, and start from there in certain ways. So those kind of strategies are also being worked out. And a lot of interdisciplinary thinking is to be inculcated, encouraged, to make the larger ecosystem to be a part of this entire defense R&D ecosystem. So these are some of the statistics. Today, there are much less number of researchers in India per capita that we are talking about. So this is some of the statistics of 2020. The number of researchers per million is much less in the India. We need to increase this landscape. The number of researchers have to increase massively, so that we can have the the kind of hands that are required to develop this defense R&D ecosystem. The kind of patent applications we are giving is considerably higher, maybe a little less than the topmost, but the kind of patents that needs to be commercialized, which are commercializable, that has to be played well, and the commercialization efforts of patents have to be increased. So there are certain takeaways from the recent last 2-3 years development. We have improved considerably in many areas. So how to go forward in those areas so that we leverage that progress in a very fruitful manner. So India needs to be self-reliant. None other than Prime Minister Modi has said that we have to be Atmanirbhar by 2047 in various crucial technologies. The move has to be very strategic, very thoughtful, taking everybody along, utilizing all the expertise that is available wherever it is available, with a complete interdisciplinary approach, is something which will ensure us as 21st century belongs to India. Thank you very much. And I do need to thank my secretary for giving this opportunity. And it was very difficult to fill into his shoes, a person of his stature. But yes, opportunity lands, and I am thankful to all the people who have given me this chance to speak to you. Thank you very much.
Thank you so much, ma'am, for sharing your expertise and setting such a visionary tone for this discourse. May I now request respected Professor Akhilesh Tyagi sir to kindly present a memento to our guest speaker, please. Thank you, sir. Employees are a valuable asset of any organization. In line with the tradition of Shriram Institute to honor the employees who have rendered several years of yeoman service to the Institute, we will now be presenting long service awards. May I now request Shri Madhav P. Shriram ji to present the long service awards to the employees. In the 35 years category we have Mr. Sunil Kumar Chauhan, working in supply chain management.
तिलक जी फ्लैश हटा लो.
Mr. Vinod Kumar Sharma, handling techno-commercial section. Mr. Pavan Kumar Sharma, a scientist working in drugs and pharmaceuticals. Mr. Kapil Sakhoja, from Marketing of Metal and Minerals Division. Mr. Dinesh Kumar Maan, an engineer working in Shriram Applied Radiation Center. In the 30 years category we have Ms. Leena Thakur, a manager working in accounts department. Mr. Ajay Kumar Sharma, working in accounts department. Mr. Naresh Kumar, a manager working in administration. Ms. Pooja Dalmia, a manager in techno-commercial section. Ms. Shilpa Badhavan, a manager in techno-commercial section. Mr. Raju Joshi, an analytical instrumentation expert. Mr. Ajay Kumar Shandon, a scientist heading residue lab. Mr. Vijay Kumar Rana, working in air laboratory. Mr. Devendra Singh, working in engineering section. Mr. Radhesham Sharma, working in engineering section. Mr. Komal Prasad, an engineer working in metal laboratory. Mr. Joshi Joseph, a scientist working in Shriram Applied Radiation Center. Mr. Tarun Verma, a scientist heading electrical laboratory.
ये तो वो भी लगा हुआ है कितना कितना.
In the 25 years category we have Mr. Naresh Kumar Dharyal, a manager working in accounts department. Mr. Shyam Singh Mahara, an executive working in central instrumentation facility. Mr. Shashi Bhushan, an engineer working in Shriram Applied Radiation Center. Bhatnagar, scientist working in calibration laboratory. Mr. Pankaj Kumar Jain, heading Quality Assurance Division. In the 20 years category, we have Ms. Radhika Sharma, a scientist working in food laboratory. Dr. Neelima Garg, a scientist working in toxicology.
विदेश में आया
Mr. Amit Bhadoria, scientist working in air laboratory. Mr. Puneet Kapoor, scientist working in metal analysis. Mr. Rakhi Singh Chaturvedi, scientist working in mineral analysis. Mr. Mahipal Singh Rawat, working in marketing of non-bio division, Uttarakhand branch. In the 15 years category, we have Dr. Mayuri, working in Central Instrumentation Facility. Ms. Nidhi Chauhan, an instrumentation expert. Dr. Priyanka Sharma, taking care of quality assurance in toxicology section. Mr. Amit Singh, scientist working in air laboratory. Mr. Gaurav, an environment protection expert. Mr. Ravi Singh, scientist working in air lab. Mr. Pushpendra Singh, taking care of information services. Mr. Brajesh Prasad Tiwari, scientist working in water laboratory. Dr. Pushplata, an expert of rubber and polymer analysis. Mr. Mukesh Kumar Sharma, manager working in marketing of non-bio division. Ms. Meenu Hasim, an executive working in quality assurance. A very special thanks to our dignitaries. Respected Dr. Ranjita Nallamalli, our chief guest, Professor Akhilesh Tyagi, Shri Madhav P. Shri Ramji, our other esteemed members of the governing board, members of research advisory committees, their excellencies, the ambassadors and high commissioners, Dr. Mukul Das, Director, Shriram Institute for Industrial Research, Delhi, invited dignitaries, ladies and gentlemen. Good evening to all. It is my honor today to propose vote of thanks. On behalf of Shriram Institute, I would like to express heartfelt gratitude to Dr. Ranjita Nallamalli for sparing her valuable time to share her immense knowledge and experience with all of us today. Her vision for the road ahead for defense R&D is very pertinent in today's world and inspiring and motivating for the scientific fraternity present here. Shriram Institute looks forward to being a part of the progress journey of the country in defense sector. Our sincere gratitude to Professor Akhilesh Tyagi, our chairperson, for his kind guidance for organizing the event. We are highly thankful to Shri Madhav P. Shri Ram ji for his wholehearted support for all our scientific endeavors. I thank our governing board members, research advisory committee members, other dignitaries for gracing the occasion. I would also like to thank the director for his meticulous planning for organizing this event and for inviting such an eminent expert as the FML speaker. I thank all heads of divisions, entire organization team, director office, Leena madam and all volunteers for their untiring effort for making this event a success. My sincere thanks to the management of Sir Shri Ram Hall for giving us the permission for organizing the lecture in their auditorium. In the end, I thank all our guests, including the students, for joining for this lecture. To conclude, I request all of you to give our chief guest and founder memorial speaker a standing ovation, please. We hope that you enjoyed the program and will again oblige us with your gracious presence in the Founder Memorial Lecture 2027, which would be the 61st in the series. Wish you all a good day. May I request all of you to join for lunch. Our volunteers will escort you for the same. But before we disperse, I would request everyone to kindly stand up for the national anthem, please.
पंजाब सिंध गुजरात